You ever been talking to an AI, you're deep in a conversation, and then poof, it just completely forgets what you were talking about like 5 minutes ago? Yeah, it's a super common problem. But what if an AI could actually remember things? Not just for a few minutes, but for an entire conversation, or even an entire book. Well, today we're going to look at a new architecture called Titans that's trying to do exactly that. And it's doing it by borrowing some tricks from the best memory system out there, our own brains.
Okay, so here's the game plan. First, we'll dig into exactly why AI has such a short attention span. Then, we're going to look at how the human brain offers a pretty incredible solution. After that, we'll introduce Titans. We'll get right under the hood and see how this thing is built. And finally, we get to the fun part, seeing what happens when Titans goes up against the current champions of the AI world. All right, let's kick things off by getting to the root of the problem. Why is it that these massive, super powerful AI models, ones that can write code and poetry, still have trouble remembering the beginning of a long document? I mean, this is really the central question, isn't it? We've all seen it. You feed an AI a bunch of context, and just a few prompts later, it's forgotten a key detail. And this isn't just some simple bug. It's actually a really deep flaw in the very architecture of how most of these AIs are built today. It all comes down to this fundamental trade-off. On one hand, you've got transformers. That's the tech behind models like GPT. They are incredibly precise because they look at every single word all at once. But that precision has a crazy cost. For every new piece of info you add, the amount of computation needed just explodes. It's like trying to have a conversation where for every new sentence you hear, you have to go back and reread the entire chat from the very beginning. It becomes impossible fast. On the other hand, you have what are called recurrent models. They can handle long stuff, but they do it by constantly summarizing the past, and that makes their memory get all fuzzy and unreliable over time. So you basically have to choose. You can have precision, or you can have length. You can't have both.
So, how do you fix that? Well, what's so interesting is that the answer isn't just to throw more computers at it. Instead, the researchers behind Titans looked at the most efficient memory system we know of, the one that's sitting right inside our own heads. And you know, this is not a new idea. Way back in 1787, Samuel Johnson wrote, "The true art of memory is the art of attention." And that is the core idea behind Titans. It's not about remembering everything. It's about knowing what's important enough to remember.
Just think about how your own memory works, right? You've got your short-term memory, which is focused on what's happening right now. It's super precise, but it can't hold a lot. Then you have this giant long-term memory, this huge library of everything you know, and you can pull information out of it whenever you need it. This dual system is exactly what the Titans researchers set out to build in an AI.
So, how do you turn that biological inspiration into actual code? Well, that brings us to the Titans architecture. It's an AI designed from the ground up to copy our brain's powerful two-part memory system. And here it is, the basic blueprint. You can see that Titans is really built on three main parts, all working together. Think of it like a little team. You've got the core, which is focused on the here and now. You've got the neural memory, which is like the long-term archive. And then you have persistent memory, which is kind of like the team's foundational rulebook. Let's break that down real quick. The core is that short-term working memory. It uses standard attention for super high precision on what's happening right now. The persistent memory is like instinct, a fixed set of knowledge. But the real game changer here, the magic ingredient, is the neural memory. This is the long-term memory that can actually adapt and learn over time. And this is what makes Titans so special. So how does that neural memory actually decide what to hang on to? This is where it gets really, really clever. It doesn't just record everything. No, it actively learns what to remember based on a very human idea. Surprise. The key here is that the neural memory is a meta model. What that means is it's basically an AI that has learned how to learn. So instead of its knowledge being frozen after its initial training, it keeps adapting. It learns what's important on the fly as it sees new stuff. It's actually learning while you're using it. So how does it know when something is surprising? Well, first, when new information comes in, it checks how much that info changes its current understanding. If it's a big change, a real, whoa, wait a minute moment, it flags that as important. Second, it doesn't just save that one surprising tidbit. It saves the context around it. You know, the how we got here part of the story. And finally, just like our brains, it has a system for letting old, less useful memories fade away to make room for new, more important stuff. Now, what's really cool is that this idea of a learning memory is so flexible that it's not just one single design. The researchers actually came up with a few different ways you can wire all these components together. First up is MAC, which stands for Memory as a Context. In this version, the long-term memory basically acts like a research assistant. It pulls up relevant files from the past and hands them over to the core, along with the current info, and lets the core figure out what's most important. Then there's MAG, or Memory as a Gate. Here, the core and the neural memory work at the same time, in parallel, almost like two different experts looking at the same problem. Then their final conclusions are intelligently mixed together to get the best answer. And finally, we have MAL, Memory as a Layer. This one works more like an assembly line. The neural memory gets the first look at the data. It processes and summarizes it, and then it passes that summary off to the core for the final, super precise analysis. Okay, so the theory is awesome. It's fascinating. But let's get to the question that really matters. How does this thing actually perform when you put it up against the best AI models we have today? The first result is it's mind-boggling. Titans can handle a context window of over 2 million tokens. I'm going to say that again. 2 million. That is not a typo. We're talking about the ability to give an AI an entire novel like War and Peace or a massive programming project and have it understand the whole thing from start to finish in one go. And here, this is where you see the real payoff. This graph shows what's called a needle in a haystack test. Basically, the AI has to find one tiny fact that's buried in a huge mountain of text. Now look at the lines for models like GPT-4. See how as the document gets longer, their accuracy just tanks? It falls off a cliff? But now, look at that red line for Titans. Even though it's a much smaller model, its performance stays nearly perfect. It's not just a little bit better, it's playing a totally different game. So what's the big takeaway from all this? It's that by teaching an AI to remember more like a person, to focus on what's important and let go of the junk, these researchers created a model that is just dramatically more efficient. It gets almost perfect recall with a tiny fraction of the size and power of the biggest models out there today. And that really brings us to the final huge question. This isn't just a small step forward, it's a potential leap. So I'll leave you with this to think about. What becomes possible when we have an AI that actually never forgets? What kind of things can we build when our creative partner can remember every single detail of a project, from the very first idea to the final line of code? The possibilities, well, they're just starting to open up.